Okay, let's go on to some other graphs. Time series graph. Basically shows change in value over time. Think stock market. I don't want to take a whole ton of time doing this. Notice that this is days starting from 0 and finishing at 8. This is some quantity that's decided, I don't know, number of glasses of water drank in a day by a family. Who knows? Okay. Speaking of drinking water, I just had a drink. Then scatter plots. Hopefully you've all seen scatter plots before. Scatter plots plot what's called bivariate data, where you've got an X and a Y, so they're related to one another. So think of this works exactly like a function would in any of your other classes. X is the independent, and Y is the dependent. All right. So we could do it like, I don't know, the length of let X be the length of time that you took on a test, and let Y be the score that you got on that test. X and Y are both related to one single data value, but they're represented as a point, X being time, Y being score on the test. In this case, it appears that the relationship is positive because it's going up. In this case, it appears that it's negative because it's going down, and then there's this fancy little line, which we'll talk about down the road, called a least squares regression line. Hopefully you've seen them before. If you have any questions, of course, you can ask me. Okay? I'll also, by the way, show you how to do those on your graphing calculator, as well as histograms. We're going to do a lot of these on your graphing calculator. All right, pie chart. Excuse me. I just pulled these off the internet. Pie charts always show percentages, always. They usually have cool little colors. Look at these. These are 3D and shaded and extra super fancy. I'm going to show you real quick how to do a pie chart in Minitab. If you let me hop over here to Minitab, ignore the man behind the curtain. Let's see. Whoops, that's not the one I wanted. That's the one I wanted. Okay. Now what I've done here is I've simply taken our data and from our frequency distribution, and all I did was make our frequency distribution sitting here right in front of us. So remember 113 to 123, it's 2, 3, 5, 8, 6, 4. And watch how easy this is in Minitab. It's pretty cool. I'm just going to highlight the data, and then I'm going to go to Insert, and I'm going to go to a pie chart, and let's do a pie chart. And voila, there it is, sitting right in front of us. Check it out. If I float above it, it tells me the percentages, which were accurate. Remember when we did the relative frequencies? Those are accurate as far as the same data. Remember 18 and 7. They round, so we're going to have a little bit of error. And you can get fancy with these things too. Let me right-click. Sorry about that, you guys. Oh, I want to cut this real quick. I'm going to cut. You can edit, or you can get fancy with these. Let me show you. Sorry about that. Somebody just walked into my room out of nowhere. Let's do a 3D. Ooh, fancy. So it looks very publishable. It's pleasing to the eye. We'll put that over here. We're going to look at it. And you can, of course, have as much fun with this as you want to. Okay? All right, let's shrink that sucker back down and get back to the business at hand. Right here. So those are pie charts. We've got a stem and leaf. And a stem and leaf, excuse me. All that this is if you look at it, it almost looks like a numerical way to write a histogram. I'm actually going to do a stem and leaf, but let's play with this one for just a sec. If you've never seen a stem and leaf before in your whole life, let's just look at it if somebody threw this at you. It says, the title of this thing is Infant Mortality Rates in Western Africa. I have no idea what the numbers mean, all right? However, I'm guessing that this means 51. Now, it could be 5,100, it could be 51,000, it could be 51%, it could be 0.51%. We don't know. But I can represent this number as being 51. So in the data set, there was probably the number 51 floating in there. This is 84, 86, and 88. This guy right here is 92. 99. There's no 10s. This is 113 and 114. This is 121. Sorry about that. 122. 124. You see how I can just pull the entire data set out sitting right in front of us just by looking at this guy, which is nice. It gives me a list. I can replicate the data basically. I'm running out of room down here. So 144, 147, 148, and 151. Again, I don't know what these numbers represent, but I can make a data set that they came from. stem and leaf is actually a pretty powerful thing because, again, watch this. I'm going to erase. It's kind of a poor man's version of a histogram. Watch this. If I go whoop, whoop, and then I go, you actually have to do it with the sound effects because it sounds cooler. And that's a histogram if I turned it sideways. I know that there are holes. I can look at this thing and start talking about center. I can talk about outliers. That guy may be an outlier. We can't really tell. I can guess where the center is, guess where the distribution, what the variation is. I keep wanting to say variance, but we'll get to that in just a little bit. Okay? Stem and leaf is pretty powerful. If we wanted to, we could do exactly the same thing. Let's go back to our data set over here. Oh, wow. We've covered a lot of material, haven't we? If we wanted to, we could do the exact same thing here and just go start at what, 1, 1. Let's do just a couple. So instead of going reverse from the stem and leaf to the data, let's go from the data to the stem and leaf. I won't drag you through the whole thing, but we'll just do a few of these guys. Sorry about that. I need a bigger eraser. All right, so the way you'd make a stem and leaf for this is real simple. I would start it at 1, 1. I'd draw a vertical line, and I've got a 4, and let's see, 1, 1, I've got a 4, and I've got a 6. I think those were, yeah, there was only 2 in there, wasn't there? So I'm going to have a 4 here and a 6 here. They're always in order. And then I go 1, 2. Let's see, no, 1, 2, 1, 2. I got 1 here. Looks like I've only got 1 of those. You guys might catch me making a mistake on that one. And then 1, 3. I've got 1 here. 133, 8, 7, 6, and I think that's it. So there'd be a 0 for the 130. There'd be a 3. There'd be a 6. There'd be a 7, and there'd be an 8. You'll often see these with commas in them as well, which kind of helps because you can differentiate between the types of curves, or excuse me, types of curves. Differentiate between the numbers. All right. Okay. Well, that about sums it up as far as graphs. There was one more. I have to do this because I'm a statistics teacher. There's one other type. It's called a frequency. I don't know. It's goofy. To be honest with you, I have never done one of these in my career. You may. That's not to say that it's not useful. It's just I feel that histograms are that much more useful. So let me show you how these work. They're called frequency polygons, and basically I'm going to do it with the histogram that I made earlier. So, whoops, I got crazy on that one, didn't I? Oh, you know what? Let's do it with. Oops! Wow. I don't know what just happened there. Let's do it with the pretty histograms. All right, let's go ahead and erase this. All that a frequency polygon does is it takes the midpoint of each class and it puts a dot at the midpoint. So it puts a dot right there, and we got a dot there, we got a dot there, whoops, and we got a dot there, and a dot there, and there, and there, and there. And then you start at 0 and you connect the dots. Pretty crazy statistical, huh? So boom, boom, and then you finish up down here. It's a polygon because it's a multi-sided shape. And then if we wanted to do it with hours, this thing's jumping 2 at a time on me. If we wanted to do it with hours, I'm going to erase this a little bit right here, and I'll change colors on us so we can see what it looks like. What we would do, we know where the middles are. I'll do it in red. Remember how this guy right here was I'm going to put him down here, 118.5. This guy was 128.5, 130, 38.5, 148.5. Remember, these are just the midpoints of each class, 168.5. And then all I do is I start at the left, put the point in the middle, put the thing in the basket, and I connect the dots, which is quite a challenge when you're trying to do this thing like that. That is a frequency polygon. So let's label it, give it a name. This is called a frequency Like I said, I've never used these. I'm sure that there are some people that could find a great use for them. I just figure that the histogram is so much cooler. All right, so that's it for Chapter 2. In class, we're going to get into some critical thinking about graphs and how they can be misleading, and we'll answer any and all questions and just have a lot of fun and do some problems. And also, one thing that we're going to emphasize is being able to use your calculator to do a lot of these graphs. Well, thanks for your time and attention, and have a really good day. We'll see you tomorrow.